Hi everyone, and welcome today to our notes titled Slope-Intercept Form and Standard Form of a Line. Now, in that title, some of this should look familiar and some of it not so much. Slope-intercept form is something from your math past. Y equals mx plus b. That should look familiar. I'm going to review it with you, but you have studied this in your math past. What shouldn't look so familiar is this one, standard form of a line. That might not look familiar. I'll tell you what it is though. It looks like this, ax plus by equals c. Now, what I need you to do, because I'm not going to spend time on the video doing it, if you missed class, I want you to sort of read through this. I say a lot of different things about equations of lines, give you some information from your math past, give you some new information of your math present, and then I say it is very easy to toggle between the two forms, slope-intercept and standard. I don't want to spend my time here on this video. Even when I flip the page, I actually take you on a journey through a review of slope-intercept form. So if you miss class, we can go over this. This is not going to make or break you for your mastery with this concept. I just kind of take you on a little journey with a table and some fill in the blank. What I would actually like to do, and whether you have this packet or not is irrelevant, on the final page of the notes, there are 3 key examples, right? If we just do example 2, you will understand pretty much everything in this lesson, both the old and the new. So I'm going to focus this video on this example. And even if you don't have this packet, it doesn't matter, because what we're going to do is we are going to simply write the equation of the line that passes through the points, -1, -3, and 3, 5, in math past slope-intercept form, and then math present standard form. So I'll be teaching standard form within this example. And that should at least get you through for today, so that by the time we meet again and you see me in person, you're able to ask some other questions, work on that mastery. So let's start with slope-intercept form. So this is complete review. We're going to start, let's just make a side here for slope-intercept form of a line. And that form we know is y equals mx plus b. And when we write an equation in slope-intercept form, we want to find both the m, or the slope, and we want to find the b, which is the y-intercept of the line. Okay. Now, you may remember when you're given 2 points on the line, you have to go ahead and calculate slope by hand. So labeling this guy as my x and my y, and this guy over here as an x and a y, I know that this is my first set and this is my second set. And my formula to find slope, m, that formula looks like this. Y sub 2 goes first. Let me just shush this up a little bit. It's your y sub 2 minus your y sub 1 divided by your x sub 2 minus your x sub 1. So dropping the correct numbers into these 4 slots, we're going to have, let's see, the y sub 2 is 5 minus the y sub 1 over here is -3. The reason I like these parentheses is really right here because of these double negatives. Minus is embedded within the formula, and then beyond that, sometimes the y sub 1 is also a negative, creating that double negative, and that can sometimes get lost if you don't keep things separated. And then this is all over your x sub 2, which is right here, 3, minus your x sub 1, here's another negative, -1. And so to finish that off, 5 minus negative 3 is actually 5 plus 3, which is 8. 3 minus negative 1 is the same as 3 plus 1, which is 4. And 8 divided by 4 gives me a nice little slope of 2. So 2 is going to feed right in for that m. So now I'm going to write y equals 2x plus b. And my last step is to find that b. So to find that b, you may remember that you're going to fill in an x and a y and solve for b. So let's go up. We could use this guy. We could use this x and y, or we could use the 3, 5. Now my choice is to use the 3, 5 because they're positives. They're easier to work with. So let's do it. So the y value is 5. The x value is 3. And I'll solve for b. Finishing this off, I have 5 equals 2 times 3 is 6 plus b. And to solve for b, I'll simply subtract 6 from both sides. 5 minus 6 is negative 1. So b is negative 1. So my final equation for slope-intercept form is going to be y equals 2x minus 1. My graph will cross the y-axis at negative 1 with a slope of 2. Very nice. Okay, now moving on to standard form. This is the new guy on the block here. Standard form is another way to represent an equation of a line. And so to get to standard form, you take your slope-intercept form and you move the furniture around. You manipulate these terms to get it in a different order. And here is the order. And you read this on the first page of your notes. The order is your coefficient and your x term go first. We call that ax. Then your by, then your y second, and finally your c. Now, a, b, and c are just numbers. These are numbers. Now, a must be a whole number. Well, what's a whole number? Your whole numbers, if you think back again to your math past, your whole numbers are 0, 1, 2, 3, 4, and on and on and on. No fractions, no decimals, no negatives, just your whole numbers, okay? Now the b and the c are going to be integers. Well, what are integers? Well, to remind you, integers are sort of like whole numbers, except we include their opposites. So your integers would be like negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, etc. And you could keep going. So the difference is b and c can be negatives. They can be positive. They can be negative or positive, but they also, integers do not include fractions or decimals. So right across the board, there can be no fractions, no decimals, but this a has to be positive. Okay, so how do we deal with it? How do we change slope-intercept to standard? Well, we click and drag this over. So let's y equals 2x minus 1. And the first thing I like to do is I like to go ahead and move my x over to the front because that's where it belongs. So I'm going to subtract 2x from both sides. That's going to give me negative 2x plus y equals negative 1. Remember, I can't put these together. They're not like terms, so I just write it as it is. The negative 2x in the front, that's the ax, and then the by, 1y plus y equals my c, negative 1. Now let's check in. Is a whole number? It's close, but it's negative, and that's a no-no. Whole numbers are not negative, so we've got to get the negative off of this 2x. The easiest way to do that, everybody, is let's multiply the entire equation by -1. If I do that and I distribute, then I get positive 2x minus y equals -1 times -1 is 1. Now let me check in with standard form. Is that a whole number? You betcha. Positive. Is this b, this guy right here, is he an integer? Think of him as -1. Is -1 an integer? You betcha. And finally, c, is he an integer? +1. You betcha. So this is standard form. 2x minus y equals 1. Standard form. Okay, so here's the deal. They're the same line, they just look different. They're presented in a different order, but they are the same line. You could even check it. If you wanted to check for sure that these really were the same line, pick a point. Pick a point. Like say x was 3. If we put 3 in here, let's see, 2 times 3 is 6. 6 minus 1 would be 5. So this line here in this form would contain the 0.35. Let's see if this one does. So if I let the x be 3 down here, then I would have 2 times 3, that's 6, minus y equals 1. Solving for y would subtract 6 from both sides. That would give me, or actually, we don't have to do that. Let's work smarter, not harder. You have 6 minus y equals 1. Well, 6 minus what equals 1? Isn't it 5? Ta-da! Same line, different presentation. Okay, the only other thing I think I should address before you attempt any mastery on these would be if you look at number or example 3 from the packet, if you have it. If not, no biggie. Example 3 wants us to do kind of the same thing. Write the equation of the line. Oh, they give me the slope. With slope, I'm going to write that down. Slope is equal to -4/5. Okay. And it passes through the point 5, -1. So my point is 5, -1. And again, they want it in both slope-intercept and standard form. Okay, so this one is actually easier because they give me the slope. I don't have to do my slope. So let's just separate this out really quickly. So slope-intercept, y equals mx plus b. Well, cool. We have m. Boom. I'm going to plug it in. Y equals -4/5 x plus b. To solve for b, I just take my point. Here's my x and my y. Y, -1. X, 5 plus b. Don't run for your calculator. We can do this in our head. See, when you take -4/5 times 5, these 5s knock out top to bottom. So you're just left with -4 plus b. You could also think of it as -4 times 5 is -20. -20 divided by 5 is also -4. And now solving for b, we're going to add 4 to both sides. So 3 equals b. Final answer, slope-intercept form, y equals -4/5x plus 3. There we go. Now, standard form, the new guy on the block. All you do, click and drag your slope-intercept up here. Y equals -4/5 x plus 3. Okay, step 1. Let's move the x term, right, way on over to the front. That's pretty easy to do. Let's just add 4/5 x to both sides. Voila. Now, that's going to give me 4/5 x, okay, plus y equals, knock these out, 3. And we're pretty much there. ax, by, 3. But here's the problem. You've got to check in. is a whole. Well, the good news is it's positive, so that's good, because a whole number can't be negative. But this 4/5 is certainly not whole. We need to get rid of this fraction. And the easiest way to do that, everybody, it's like you're just going to multiply, okay? And think about it. What would knock out the denominator here? What would knock out a 5? Well, we kind of did it up here, right? A 5 knocks out a 5. So let's multiply by 5. That way, when I distribute 5 times 4 over 5, these knock out, and I'm just left with 4x. You could say 5 times 4 is 20. 20 divided by 5 is 4. So 4x plus 5 times y, 5y, equals 5 times 3, 15. Now, whole, yep, check. Integer, check. I for integer. 15, integer, check. There is your standard form. 4x plus 5y equals 15. This is the same as this. It's just presented in a different outfit. Isn't that crazy? I'll show you how. Let's just check it. So if you wanted to check for sure, let's just let x be something. Let's let x be 10 because it's easy to work with. So if you put a 10 right there, right? Put a 10 there, right? So you're taking negative 4/5 times 10. Well, negative 4/5 times 10 over 1. 5 knocks out a 10 twice. And negative 4 times 2 is negative 8. See how that's negative 8? You could also do 40 divided by 5, which is 8, negative. And then negative 8 plus 3 is negative 5. So on this side, when x is 10, y is negative 5. Let's see if it is over here too. Let's let x be 10. So that would give me 4 times 10 plus 5y equals 15. That's 40 plus 5y equals 15. I would subtract 40 from both sides, giving me 5y equals negative 25. Divide both sides by 5, and y is also negative 5. See how the y's match when x is 10? So this line would also have the point 10, negative 5. So you're just translating. It's like translating one language to another, like English to Spanish. You just translated slope-intercept form into a different form, which we call standard. Okay, I hope that's enough to get you through. Math Pass meeting with Math Present. It's not the full notes. If you have the packet, no, it's not the full notes, but it should be enough to get you through and get you onto the mastery. Good luck, and I'll see you next time.